Okay, so today we're going to start 6.1 key features of exponential functions. We're going to use the same features we've done before in the past and elaborate that into an exponential function. So we're going to recognize those key features and describe them. So we're going to start with graph and identify the domain, range, intercepts, asymptotes, and behavior of 2x. Well, we know that 2 is our base. And this is an exponential function because we have an x in the exponent. The variable's in the exponent. So we don't know what this is supposed to look like yet. So we're going to make ourselves an XY chart and find out. So if I have negative 4, negative 2, 0, 2, and 1. When I plug those in, I get 4. Oh, nope, I don't get 4. I get 2 to the negative 4th. So 2 to the negative 4th, which is really 1 over 2 to the 4th, which is 1/16. So then I also have 2 to the negative 2. So that's 1 over 2 squared, which is 1 over 4. Now remember, a negative exponent reciprocates, so a whole number becomes a fraction becomes a whole number. 0, so I have 2 to the 0. This is the other exponential rule that we need to remember, that anything to the 0 power is 1. So then I have 2 squared, which is 4. Actually, I probably should have done 1 first, huh? So 2 to the... We weren't going to do 1, we were going to do 2, 4. So I just... maybe I forgot to finish my 4. So 2 to the 4th is 16. So now I'm ready to graph this and see what shape comes out of it. So 1, 2, 3, 4, 5, 6, 7, 8. Or maybe I should have made my... I might have to fudge a little. 8, 9, 10, 11, 12. So we know 13, 14, 15, 16. So my graph, I did not make it big enough, did I? Okay, so I have 0, 1. 1, 2, 3, 4. And 1, 2, 3, 4. And at negative 4, I have 1/16. So that's really down here, isn't it? Almost touching the x-axis, but not. Negative 2, I have 1/4, so it's a little bit bigger. I have 1. At 0, I have 1. 2, I have 4. So 1, 2, 3, 4, and over. If I wanted to do 1, I know 2 to the first power is 2, so I could put that as well. And then at 3, it's 8, so 4, 5, 6, 7, 8. And these are numbers I didn't put on my table, but I know them, so there's no reason. And then up here we get to 16 at 4. So this graph is going to go, and it's going to take a swift turn and go up. It's what they call an exponential growth model, because it starts off kind of slow, and then it's going to go boof. And that's because our base is 2. If our base was 5 or 6, think about what would do. That would get closer and closer to that y-axis. So we need to identify everything on this. Our domain, actually I'm covering it up when I'm writing it, so how about I write it somewhere else? Okay, so my domain is going to be all real numbers. There's no restriction to what I can put in there. My range, we need to talk about that one a little bit. Anything I put in there, because I plugged in a negative number, I didn't get a negative y, did I? Any negative value I get is going to give me a fraction. So like if I did 2 to the negative 84th, that's 1 over 2 to the 84th. And I think somebody told me that was like something like 4,000 something. So if I have 1 over 4,768, which is not right, that's going to bug me that I don't know. Let me check it out here. So 2 to the 84th is a big number. They don't like it. It's not even that. It's that number. So if I had to, I think the person told me wrong. So 2 to the 84th is 1, 9, 3, 4, 8, 2, 8, 1, 3, 1, 1. And that's 2, 4, 6, 8, 9. With another 16 zeros behind it. So that's a large number. So it's not 0, is it? It's huge. 1.9 times 10 to the 25th. It's a huge denominator, so that makes the whole thing pretty close to 1, but it's not ever going to be 1. So y is going to be greater than 0. My horizontal asymptote is y equals 0. I never get there. I never touch it. It's an imaginary line. It is increasing.
Mask. Let's call it mask all makes classroom man.
Okay, so I think we got everything. I got interrupted. Sorry. Okay, so domain, range, horizontal asymptote, increasing. Oh, y-intercept. Y-intercept is 0, 1 because anything to the 0 power is 1. So this is what you're going to be identifying on those graphs. Ron, I'm recording. Okay, so our next one we're going to do is 5 times 1/2 to the x. So it looks exactly like what we had before, except we have a coefficient out here. We have an a. Ooh, it's coming back to haunt us. Our base here is 2, and our base here is 1/2. So let's see what happens when we do this graph. So x and g of x. And this time I'm just going to do 2, -2, 1, 0, 1, and 2, because I just don't want my numbers to get too big too fast. Okay, so I'm going to have 5 times 1/2 to the -2. I'm going to have 5 times 1/2 to the -1. I'm going to have 5 times 1/2 to the 0, 5 times 1/2 to the first, and 5 times 1/2 to the second. So let's go back. Remember that negative exponent reciprocates, so if you reciprocate a whole number and get a fraction, when you reciprocate a fraction, you get a whole number. So I have 5 times 2 squared. 2 squared is 4, times 5 is 20. And then I'm going to have 5 times 2 to the first. So I have 10. And anything to the 0 is 1, so I have 5 times 1, which is 5. And then 5 times 1/2 is 5/2. And 5 times 1/4, because it's squared, it would be 5/4. So the other graph we did, I'll put that in, went from small to large, and now we're going from large to small. So we're going to have some other things happening here when we do that. Okay, let's see, negative, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yay, medal for the day, I can count. Okay, so -2 is 20, and -1 is 10, or -1 is 10, excuse me. And then 0 is 5. And I have 1 and 2. And so 5/2 is 2.5. And then 1 1/4. And if I kept going, it's just going to get closer and closer. Now I'm going to turn my paper so I can draw myself a nice line here. And then I'll turn it back. A nice curve, I should say. It's not a straight line. So I have this. So we have this when I have 1/2, and we have this when I have 2. So this one is growing, and this one is decaying. So my domain is still, well, let's do the y-intercept. I like the y-intercept first. It's just nice to do. Okay, so the y-intercept now is 0, 5. And the reason why it's 0, 5 is because we multiplied everything by 5. We multiplied everything by 5. and that's what's going to do that for us. So then I have a horizontal asymptote still at y equals 0. Graph didn't move up or down, it stayed where it was. Domain of x is an element of all real numbers, and range that y is greater than 0. And this one is decreasing because we're going down, we're taking that fraction down. So here's our parent function. This is what we have. It should be very similar than what we've been before. A is that making it wider or smaller. Now we do have the combination though, narrower or wider. We do have the combination though of the B and the A will both affect that. So you just have to be aware of that a little bit. If I had a negative out here, I would reflect over the x-axis. This should have parentheses around it. That H is going to go left and right, opposite direction, and K is going to go up and down. B is considered your ratio. We call that our ratio of change. The right here is growing, so it's a growth. And this is decay. And really, the left, I have it backwards. The left is really only your parent function. This is just a reaction to what we do to the base, but I wanted to show it to you. Okay, so over here you notice that B is greater than 1, and B over here is 0 to 1, so it's a proper fraction, but you notice 1 is not included in either. 1 is not, with a base of 1, is not considered an exponential function. That's just a linear line. It's just a horizontal line. So my y-intercept is 0, 1, and that is our vertex per se. That is what we're going to be moving left, right, up, and down. That's our anchor point. Our horizontal asymptote is y equals 0. Our domain is all real numbers. Our range is y is greater than 0. And we are increasing. Now, if you want to do x approaches, as x approaches in positive infinity, y approaches positive infinity, you can write it that way for end behavior. You also need to think about your left behavior as x approaches negative infinity, y approaches 0. It does not go past that horizontal asymptote. I just mostly concerned about is it increasing or decreasing. So on a decay function, everything is the same. Our vertex is still the same. Our horizontal asymptote is still the same. Our domain and range, but we are decreasing. Now. Okay, so let's use that H and K and all that. So, well, this is a negative. That's that negative A. So what it's going to do is instead of going up, it's going to go down. So it's not going to change my y-intercept. It's still going to be 0, 1. My horizontal asymptote is still going to be y equals 0. My domain is still going to be x such that x is a set of all real numbers. But it is going to affect my range and my end behavior. So let's graph it and see what happens. So I know it goes through 0, 1. Well, it went through 0, 1, but I reflected, so it doesn't go through 0, 1 anymore. It's going to go through 0, negative 1. So it was originally here. I'll put that there for you. And now it's going to go here, and then it's going to go what? Oh, let's get a point. Let's do like 2 and see what happens. So if I plug in 2, I get negative 3 squared, which is negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. and we've got 2, 9, and we go through here, and so my graph is going to go here and go down. So we're there, and so my range is no longer greater than 0, it is actually less than 0. And we're not increasing anymore, we are decreasing. Okay, so our next example we have is g of x is 3 to the x minus 4. Well, this minus 4 is my k. So that means everything is going to move down 4. So my y-intercept was, or my vertex, we'll do that just in case, because it could change. The vertex was 0, 1, and now I'm going to subtract 4 from that. So it's going to be 0, negative 3. So it's still my y-intercept. Don't have to go look for another one yet. So my horizontal asymptote was y equals 0. I'm going to subtract 4 from that. So now it's y equals negative 4. My domain isn't ever going to change unless I throw it into an application problem where I talk about time or something that I can't have negatives, things like that will restrict it. My range, though, is also going to go down 4 because it's linked directly to my horizontal asymptote. So it's not going to be greater than 0 anymore. It's going to be greater than, it's going to be y such that y is greater than negative 4. And we didn't reflect or anything, so it is should still be increasing. We'll check. When we're done graphing, we should always come back and look at our work and make sure we're right. Okay, so x, y-axis. So 1, 2, 3, 4 is my horizontal asymptote. My y-intercept is 0, negative 3. Let's plug something in on the right. How about 2? So if I have 3 squared minus 4, it's 9 minus 4 is 5. So at 2, 1, 2, 3, 4, 5. We've got 5. And so my graph is going to come up. Yep, I probably didn't curve enough. Let me take this from another angle. Great thing about the sketch, we'll just make my point bigger and we'll make it work. To give me an idea what this is supposed to look like. So again, we're not having to do our table anymore. We're just using our H and our K. Okay, 2 more examples and we'll be done. Okay, so I have 5 to the x plus 3. Those are in the exponent. Make sure your exponents look like exponents. So this says everything moves left 3 because that H is always the opposite. So we started our vertex at 1, 0, and I'm going to subtract 3 from the x's because they're horizontal. And I'm going to get negative 3, 1, which is no longer an x-intercept, it's just a point. So now to get the x-intercept, like any other equation, we have to plug 0 in for x to find it. So 5 to the 0 plus 3. Well, 5 to the 0 is 1 plus 3 is 4. So our y-intercept was 0, 1, and now it has moved to, let's see, 0, 4. So it's the vertex and the y-intercept. So this is our vertex, and this is our y-intercept. Horizontal asymptote is not changing. It did not go up or down, so it's y equals 0. Domain, and I don't know if we said it was increasing. Yes, we did last one. So range, domain is x such that x is a set of all real numbers. Range is y such that y is greater than 0. We didn't go up or down. And we should still be, again, be increasing. So we'll check that out and make sure we're right. Okay, so I have negative 3, 1. And I have 0, 4, 2, 3, 4. And I have 2 points here, so I don't need any more. I don't want to find any more. And that, in order to fit this, it's going to have to be increasing, so we are right. Okay, so our last thing here. The last thing I've got here is I have a negative x. So that's tied to the x, so it's not a reflection over the x-axis anymore, it's a reflection over the y-axis. So instead of going up here, it's going to go down here. So my y-intercept is not changing. I am not moving this left or right. It's my y-intercept, it's my vertex. Same thing here is 0, 1. My horizontal asymptote is not changing. I'm not going left or right, up or down. Well, left or right wouldn't have changed it anyway. Domain is not changing. I'm not tying this to an application problem. Range is not changing because I'm not tying this. I'm not moving it up or down. But I bet you it goes decreasing because we've reflected it over the y. So 0, 1. I'm going to pick a point to the left. So I have I'm going to use x equals 2 or negative 2. So I have 5 minus a negative 2. So that gives me 5 squared, which is 25. So at negative 2, I go clear up to 25. So in order to fit those two conditions, this is going to be decreasing. Like I had estimated before or projected before, that it would be decreasing. So it is decreasing. Oops, got off camera, sorry. So nothing changed here, but that x is always tied to the negative is always tied to the x, and it will be reflected over the y-axis to show that graph.